Okay, so there are two questions off the homework that I want to go over with you guys. The first one is number 9. This is on the back of your homework, which is on fundamental theorem of calculus. So I'm just on this back side here. The reason I want to go over it with you is because the numbers come out to be ridiculous, and I feel like most of y'all are going to do it and then think, oh my gosh, I'm wrong. So you have your v of t. It's given to you right here. Okay, and then it says, what is the velocity at 3? So remember, if I want the velocity at 3, I just need to take 3, plug it into velocity. So I do v of 3 equals the integral from 0. And then remember, I'm plugging in 3 here. So 2x is going to be 2 times 3, which is 6. 3t plus 2 to the 4th dt. Okay, then this is where it gets kind of weird. Okay, because when you plug it in, you do math 9. That's how your integral comes up. And then we're going to go from 0 to 6. And then we're going to type in our equation, which is 3x plus 2 to the power of 4 dx. Okay, you type it in and you get 213,331.2, and that would be meters per second. Okay, so obviously that doesn't really make sense in terms of it being a car's velocity, but just pretend, okay? Part B, we want the acceleration at any time. Acceleration is the derivative. And if I want the derivative of v, that's going to be your second fundamental theorem. Here's why. Acceleration is going to be the derivative of the integral from 0 to 2x of 3t plus 2 to the 4th dt. And whenever you have a derivative of an integral, that's when you're doing second fundamental theorem. So remember, all that you have to do is take the 2x, pop it in right there for where the t is, so that instead of 3t now, it's 3 times 2x. And 3 times 2x is actually going to be a 6x plus 2 to the 4th. Now, don't forget that since your endpoint wasn't just an x, since it was a 2x, you're going to have to do chain rule. The derivative of that endpoint 2x is times 2 at the back. Okay? Now notice that's the acceleration at any time. We want it at 6. So then we would say, okay, well then acceleration at 6 is going to be 6 times 6 plus 2 up to the 4th times 2. And then remember, this is a calculator question, so you shouldn't be doing all this stuff by hand. Okay, you do 6 times 6 plus 2 up to the 4th times 2. Just like that. And you get 4,170,272 meters per second squared. Okay, now again, obviously if this is a car, that doesn't really make sense, but just pretend, okay? All right, last part, average acceleration. So if I have velocity and I want average acceleration, remember that average acceleration is going to be either the average rate of change or the average value. So think about if this is velocity, I want average acceleration. Acceleration is the rate of change of velocity, so that would be AROC. So I do v of 3 minus v of 0 over 3 minus 0. Okay, then remember, I already found v of 3 up here in part A. V of 3 was this number, so it will be 213,331.2 minus. And then for my v of 0, think about for a second, if this is my velocity, then my v of 0 is going to be the integral from 0 till 2 times 0, which is 0 again. And so remember that any time that you have an integral from the same number on top and on bottom, that's going to come out to be 0. Okay? So then really it'd just be this number over 3. Time would be meters per second squared. Okay? Good job.